BizBuzz, congrats on the first. Hope you're doing well. Hayden, I'm doing good. How about you? Okay, we're live on YouTube too. It has been a minute. Glad to hear it's going well. Where the hell was I? I completely lost track of time until like 15 minutes ago. It's like, oh, Brad, I usually start the stream now. So, um, okay, maybe we don't have anything that's pending for us right now, so I might do a little bit more E&Ms. I really should get back to mechanics too at some point, but I think I'm gonna do E&M. But I've been working on this one problem for the last like 2 streams, now 3 streams with this one. Uh, and things keep getting too busy to actually work it out, which is a good problem to have. So this problem is related to AC circuits, Hayden. Um, this one is asking about an RLC circuit, specifically an overdamped one, which I think is when the resistance is very high. I don't think it's only the resistance. I think it's like maybe a combination of the R, L, and C constants. Yeah, it is. But this problem builds into the problem I actually want to do, and so you basically take a trial solution. Well, this differential equation dictates the voltage in the RLC circuit at any time. Yeah, and you take this trial solution for the voltage and plug it into the differential equation, and you solve it for beta, because that's the only thing you really, as long as you find a valid solution for beta, then you have the solution to the differential equation, because we guessed that this is it. We just need to figure out what beta is. And so I found that beta, there's 2 possibilities for beta, because of the plus or minus from the quadratic formula. And then they ask you to think about what happens if R is very large, what the solution looks like for large T also. So I found that for the plus solution for beta, which I called beta 1, for a very large R, beta 1 becomes positive infinity. For beta 2, the minus, for very large R goes to 0. Is that right? Yes, because that's what I did in the green bubble thing up here. Okay. And so, oh yeah, this is where I got stuck. So looking at the actual solution now, for very large T and very large R, up here we have negative infinity times infinity, which is just e to a very large negative number. So e to a very large negative number, excuse me, goes to 0. Over here is a little more complicated, and I was still trying to figure that piece out, I think. Because beta 2 goes to 0, but T goes to infinity. Hey Jed, happy Thursday to you too. Uh, and I feel like it shouldn't be something that's very complicated to do. I feel like I'm just missing something here. Hey, Jasu. Common factor? I don't think there's a common factor. Yeah, so I'm concerned about this term here. Um, beta 2 is this right here. And for a large R, I concluded that that becomes 0. Maybe I should verify that. Um, because they're basically asking what happens with this equation for very large resistance and very large time. Beta 1, beta 2 depend on resistance. The yield term goes either 0 or 1, is either significant when added to the first term. Well, the first one is 0, but I don't think it's accurate to say 1. Is it? No, it is. There's a negative sign there too. Uh, oh, maybe that's a good point. Let me. I want to take a look at beta 2 in Desmos to make sure I'm doing that limit right. Is that what I have? Yeah, okay, that's basically what I have. And so for large x here, it does indeed go to 0. Okay. It goes to 1 over infinity, which approaches 0. Big 35. Not as big as that one the other day. It's my 35, and I'm damn proud of it. I think it's Joseph or Laz Joma who has the biggest streak that I'm aware of. E to the 0 is 1. Ugh. This is basically a multivariable limit. Like, could we think about e to the minus xy, and we'd be letting x go to 0, y go to infinity? Let's look at that in Desmos. It's it probably depends on the function. That's what I'm struggling with too, Jed. Um, and I think it basically comes down to what I just put with e to the minus xy. Ooh. So x-axis is there. Y-axis is the it should be there. Wait. Is that a right-handed coordinate system? It should be that. That looks like there's a negative. I can't read. There's not enough contrast. Wait, wait. X? Oh, no, that is right-handed. Okay. So we're letting X go to 0, Y go to infinity. So looking along the Y-axis at very large Y values. And that's just blowing up to infinity. Really? I think they're essentially an equal rate, Jed. They could be off by like a constant like factor, but for the sake of the limit, that's not usually, that doesn't make a difference for convergence or divergence. This is like a physics book. They shouldn't be like, it shouldn't be this difficult. I feel like there should be some kind of simpler conclusion, like, or some simpler way of thinking about this. Like, I think it should be 0 is my issue. It's just a little bit difficult for me to justify from the math. Because it is an overdamped circuit. I can see it maybe just going to the constant b. But if it's overdamped, it should just trail off. Like, where do they talk? Maybe they'll talk about overdamped here. Did they talk about it even earlier? I don't think so. I think they talk about it later. No? Yes? No? Yeah, yes? That's RLC. There we go. This even makes a reference to 8.4. That's something that we're working on right now. So this is what I've had in my head for saying, this is the overdamped case. It should just trail off to 0. Am I sure about beta 1 and beta 2? Maybe I should think about them more. It's possible that I messed something up. Ooh, a Quora thread. Let's see what's happening with this. Yeah. That this kind of, this feels like it tracks. And so that's why I'm thinking that there should be a, either I made an error like Jasu is suggesting, or I'm thinking about it wrong. Just say 42 and be done with it, true. Is this the same DPQ that I have? Yeah, it is. It's actually like literally the exact same. Equation 8.2. And actually, I should mention that an alternating current RLC circuit is the exact same thing as a mass with a spring that has friction, I believe, is the situation. But like they're exactly like you have the constants shuffled around a different way, but it's basically the exact same behavior. And so this is the circuit equivalent of friction being too high and the oscillations eventually stopping. Yeah, that's what they talk about. They say this. They don't say friction. They say the spring is in a fluid that hinders the motion. I assume that's intentionally done. Maybe friction is a little bit more difficult, but it's still just. I think you have to represent friction in the same way as being proportional to velocity. I think. Um, or friction is maybe just potentially more complicated, and the fluid is simpler. Either way, it's not important, but there is like a very like mechanical equivalent to this. What am I actually? Oh, should I be trying the cosine? Is that my issue? Exponential trial solution. No, it should just, there shouldn't be the cosine. Or should it? Maybe it should be. But it's weird because the answer for v of t does not have this cosine thing. Oh, wait, no, it's because it goes away in this case, maybe. Is it? R, we have to assume R is greater than 2 root L over C. It's like a yo-yo doesn't want a yo-yo anymore. It ends one of 3 ways. The yo-yo-er is done, catches the toy and puts it down. The yo-yo-er doesn't yo or yo well, so the toy ends up dangling completely extended on the string. Or 3, the string breaks, sending the yo-yo onto the yaw axis where anything is possible. Oh my god. So wait, what happens to my solution if we force, where was I? Ugh. It famished. If we force R greater than 2 root L over C. Maybe that's what I need to think about. So if we solve this equation for R, yeah, this is where it comes from. 2 root L over C. I made it equal to 0 for the critical damping case, but it's gonna start on some more reviewing. I was hoping finish reviewing, both getting sick and all kind of delayed. Oh yeah, fair. That'll happen. You have a question, Lecture Geek? Is it the Riemann hypothesis again? No? Is it? It's gonna be Navier-Stokes then, or something like that. All right. What's your question? Okay, yeah, Collatz conjecture. There you go. Buy one of those spicy noodles. That does sound good. I like the cocksucker question true. Let me see if I can find it. Yeah. Uh as far as instant ramen goes, this stuff right here is it's really spicy, but it's really good. As it looks a bit more like that, the version I usually like see, but oh yeah, that'll clear your sinuses. That one I'm suffering as I eat it, but it tastes too good. Okay, I'm generally confused with what they mean by exponential trial. The Harry Ball theorem, I have seen that before, yeah. Hey, Hobie. Oh, this is not gonna go well. The Harry Ball theorem. Had some heavy broadsword practice tonight. Wait, I can't tell if you're making a joke that I'm not getting or if it's actually related to like the martial arts that you do. Lotus? Oh, okay, Eskrima. Okay, yeah, that I would probably feel like I've gotten beat up after that. Law of the unconscious statistician. That's new to me. So I guess it's already happened by the sounds of it. Yeah, I bet I would be pretty freaking sore after. I did a little bit of taekwondo as a kid, and they did give us like basically two long like drumsticks or just like sticks. Uh, but we never actually like fought with them. It was more like choreographed like moves. So there's no real like risk of getting hit. Differential expresses the expected value function g of x for any variable x in terms of g and the probability distribution of x. So why is the statistician unconscious? Liability of the United States? That's really clever, Joseph. Ugh. Oh, okay. Etymology. This is what I want. Wait. Okay. I thought there was something a little bit spicier than this, but fair enough. It's a funny name still. No contact, just that he got us to do a bunch of moves with Chinese broadswords and switched to light sticks, using way more speed and hit movement to get it going. Good times. I just tried to reach over, pressing on my side table. Oh, okay. So you're still like swinging around, you know, heavy broadswords. Funny name. Shoulder arms are not happy. Yeah, I bet. Cox pinch method? What? Oh my god. That's a new one. Debone it. I Hey Phobos. Okay, I need to know if that was named on purpose or not, but I'm gonna hide my screen while I type this into Google just so I can, you know, make sure nothing too strange comes up. Okay, it looks like we're okay. There's no actual pinching involved on this screen that I can see. I just want to hear the origin of the name here. Is it a is it like the Cox Zucker machine where there's someone named Cox and someone named Zucker? I know, I just have a Wikipedia page. Oh well. 4 out of 5 psyches agree. Mood and concern. That's a funny bit. I'm sure you aren't a math nerd. That feels like an insult. We're all math nerds here. The first line of the intro. In this paper, it showed it possible to divide by 3. Specifically for any sets A and B, there's a 1-to-1 correspondence between 3 times A and 3 times B. Then there's a 1-to-1 correspondence between A and B. Oh my god. It's 35 pages. What is this? Is a new one. It means 1-to-1. I wonder how they intend you pronounce this symbol. I'm trying to invent a funny name for it, but it just kind of looks like a sideways butt to me. A butts B? I don't know. Money for a PhD well spent. I mean, oh, I wonder if this it might not even be a PhD like thesis. 1994. I don't know where it's actually published. A 1-to-1 to B. I guess so. 1-2-1-2. Yeah, yeah. Conway? Do you like recognize that name? Why is there an asterisk, by the way? Is this like baseball? Is he like doing brain steroids? Never approved of the exposition, which he regards as full of fluff. The exposition. Or this exposition. I don't know if that means just the introduction or the entire thing. Hey, Brian. You sure did. Scroll through and see the pretty lines. Oh my god. That's like a mega tilde. We don't want those weenie tildes around here. Look and say sequence on Wikipedia? Okay. Table 1. Whatever this table is about. Great caption. Symplectic manifolds. Poisson manifolds. Courant algebroids. This feels like something... I feel like if you ask ChatGPT to make up some math-sounding words, courant algebroids will be one of them. Did I read the title? I don't know. Some title containing the words homotopy and symplectic, e.g. this one. That's funny. Wait. Look and say sequence. Good math to use for protein sequencing? Wait, well, is there a joke in there that I'm not getting? The Conway one? Yeah, that's what I was thinking of, but I wasn't even actually reading it. I was just looking at the pretty pictures. Not a joke. Oh, okay, okay. Conway's constant is the unique positive real root of this polynomial? Why? One. Oh my god. Imagine trying to solve the polynomial for yourself based off the book, but there was a misprint in the book and you can't get it for the life of you. Look and see even starts with 1, which is 1, 1. So the next number is 11, which is 2 1s. So the next one is 21. Oh, that's hilarious. And this polynomial represents that because you have 1, 1, 2, 1, 2, 2. Or 1, 2, 1, 1. Introduced to it by one of his students at a party? Professor going to the parties? That's interesting. We can say sequence is asymptotically c to the n, where c is a root of that crazy polynomial. It's interesting. It's like, it's exponential. That's kind of crazy. Texas sharpshooter problem. The small circle contains all 3 points. Wait, the small circle contains 3 of the points is found. In the bomb problem, the small circle contains all the points is found. Okay. Oh, wow. Interesting. Conway's Game of Life? Is that just the normal Game of Life? Oh, okay, maybe it's different. Conway's Game of Life. Oh, I've seen this. Yeah. I feel like I maybe saw a video about this. Yeah, it's a 0-player game. I remember that. You don't need anyone to play it. And you can get different kind of cool patterns depending on your starting conditions. Okay. Anyway. What was I doing? Oh yeah, okay. Circuits, right? Oh, Colton. Yeah, sure. If you want to share that. Where was that work? It's not that one. Oh my god. There. Okay, so last stream Colton asked this question at the top here. I did it in a multivariable way, but I'm pretty sure there was a single variable way that I couldn't quite work out. And Lubert suggested there's probably a linear algebra way to do it as well. But it sounds like Colton found the single variable way of doing it. Oh shoot, I'm not. Oh my god. Okay, this is the problem that Colton asked. I didn't realize I wasn't showing the thing. And Colton's over in the YouTube chat. And so the work that's right below it is the multivariable way. Do I still have it? Oh, I deleted it. Shared? Okay. The multivariable way, or I'm sorry, the linear algebra way apparently involved noticing that that function is the same thing, I think, as x, y. I might be misremembering the matrix equation exactly, but something like that. I might have that equation slightly wrong though. I feel like I'm missing a 1 somewhere in the 2x2. But we didn't know what to do with it from there. Okay, I guess I'm gonna bring a new page in. So this is the solution that Colded came up with. Ah, frickin' journal plus plus does not handle images that are too big for the screen well. Okay. So you call lambda the minimum distance between 2 points where x1 is greater than 0 is greater than x2. You set it the distance formula. Yep. Hey, Fembox fan. I don't know why I said your entire name. Lambda represents the minimum distance between 2 points. x1, y1, x2, y2 are on the respective branches. Right here, you're looking at y equals 0, x equals plus or minus 1. Y and y prime, the derivative is always greater than 0, sure. Claim normal containing the shortest distance will pass through the origin. I assume like the normal line with the shortest distance will pass through the origin. Mr. Fembox, yeah. Cold is saying yes to that? Okay. Mr. Mr. Fembox is my father's name. So how do you prove your claim here? You look at the derivative. And so the derivative is slope of the tangent. So if you want the slope of the normal line, you flip it and put a negative sign in front, and you multiply it through by x squared. So that looks good to me. Now what do? You equate the equation for the normal lines through x1 and x2, because we do think they should be equal. Yeah, I like that. And you look for simplifications. You find that x1 squared is equal to x2 squared, which implies either x1 minus x2 equals 0, but that's not possible by the constraints of the problem, or x1 is negative x2. And that apparently implies y2 is minus y1. So normal line joining x1, y1, x2, y2 has a midpoint at their average, which is 0, 0. Okay, hey, that's pretty clever. Yeah. We find the minimum distance from the origin and double it for lambda. Oh, wow. So now instead of x1 and x2, you can just have x1 in the origin, and now we only have one variable to worry about. And so you plug it into the distance formula. This is Colton, the person who asked the original question over in the YouTube chat. So you're going you have this in the radical, and then you suddenly find the minimum of it is this number here. How did you do that? Papadoria, there's no line. We're looking through this work from Collatz right now, just out of interest, but there's no queue as of now. Or like, you know, I had to look at a question from you right after we're done with this. I assume you just do this off on the side or something. You take the derivative and find the minimum thing. You're saying 4x minus 2 over x cubed. Okay, yeah, so you take the derivative and set equal to 0. Yeah, Papadori, this is the problem from last stream. This is work that Collatz did, and we're just kind of like looking through it and seeing the technique. It's pretty freaking clever, I gotta say. Okay, and so you find that for the distance from the origin to x1, and then as proposed, you take lambda equal to twice that. What's happening down here? Why is that your answer? Why isn't this our answer? We're supposed to find... Oh, okay, so like the actual question wasn't the actual... It wasn't... They weren't asking you to find the minimum distance. They were asking you to find the square of the distance times 3. I guess that's engineered to give you a whole number. But I do want to look at the number you put for lambda there and see, like, we got like 0.84 or something, right? Just want to like see for myself that that matches. Two root 2 parentheses root 2 minus 1. Wolfram, you're kind of the worst sometimes. Okay. 2 square root 2 parentheses square root 2 minus 1. 1.8209? Oh, maybe that was it, yeah. This thing was like, it looked like half the golden ratio, but it wasn't quite. Wow, nicely done. It's a nice technique there. Venlox, I was talking to Lubert about the method he had using matrices yesterday. That method comes up in linear algebra regarding the notation of axes in order to remove the xy term in the equation. It's a nice approach to do that using matrices to reduce it to a standard hyperbola. Nice. Yeah, I saw yesterday you're talking about like it's just a hyperbola rotated by 22.5 degrees, I think. I just noticed a little about how hyperbolas work. Oh, I guess if you know the vertex of the hyperbola, then you're in business, right? Or like the vertices, because it's just going to be the vertices. Is that possible to get in the standard form for a hyperbola though? If it's rotated, I feel like it's probably not. Yeah, Papadori, feel free to drop your question in chat. So I think we're coming to the end of this one here. Yeah, Colded. I guess if you could figure out how to unrotate it, which is probably not trivial. There's probably some like I assume it's not hard to get the vertices of a hyperbola. Um, It's rectangular hyperbola when you plug it into Desmos. I don't know what rectangular hyperbola is, to be honest. Is it back to get the standard form possible to do with matrix methods or just substituting the right expressions for the x's and y's? Okay. All right, let's dive into a certified Papadoria question. Oh, jeez. Professor said he would quit his job if somebody got this, and he was not joking at all. The head of the mathematics department in our college approved and signed the deal. He's been there for 30 plus years. Oh my god. Okay, well, I'm probably, if that's the case, it's kind of a long shot to actually solve this, but let's at least rewrite. Let's just look at it with like writing rather than text formatting. So this is the definition of a sub n. We want to prove. I mean, I guess there's not really a huge point in rewriting this piece, but I'll do it anyway. For all like natural numbers a, a sub 0 equals, I assume that's alpha? Or wait, or no, it's probably just a. To match that a, or I assume it's the same a. For all n greater than n, a sub n belongs to 1, 2, 4. A sub n plus 1 belongs to 1, 2, 4. A or alpha? It is alpha? Okay. I'll make it alpha just to match it. But yeah, you're right. It doesn't make a difference. Job security? Yeah. What a cursed sequence. So for any natural number you start with, you eventually fall into 1, 2, 4 cycles, I guess. After some initial fluctuations, potentially. Okay, the chance that I can actually solve this is like, I would give it a 10 to the negative 10 chance. But let's at least explore and play with it a little bit. If we take alpha equals 1, what happens here? Is that a sub n plus 1 or a sub n plus 1? I'm pretty sure these are all like parentheses like that, Fembox. That's my guess at least. A sub n parentheses plus 1 seems weird to talk about here. My assumption is right? Okay. So if a sub 0 is 1, what is a sub 1? A half plus sine squared pi over 2. 2.5 plus 1. Sine pi over 2 is 1. Check my plus 1 at the end of line 1. Oh, shoot! Ha! Wait. That's I forgot about that one. Papadoria, did I get that part right? I assume it has to be like this. That part is right? Okay, yeah. Because it would be weird to define a sub n plus 1 in terms of a sub n plus 1. So it sounds like this is right. It's a character limit on YouTube. Oh, okay, yeah, fair. 2.5 is 5 over 2. 5 over 2 plus 1 is 7 over 2. So we immediately get to 4 here. Now what is a sub 2? We get 2 plus sine squared 2 pi? 2.5 times 4. 5 over 2 times 4 is 10. How is this going to decrease? It seems like it's increasing, is it not? Oh no, because never mind, because sine is sometimes 0 and sometimes -1 maybe. No, we never get -1 from this. We will get 0 though. I mean, we can get -1 for alpha equals 3, but for alpha equals 1, we'll never get -1. Okay. So we get 2 plus 0. So we just get 2. All right, alpha 3. 1 plus... I assume this part is good to establish because this is going to be presumably a pattern we always fall back into. Honestly, this feels like a rephrasing of the Collatz conjecture. Or like, it feels like a similar... a similar vibe. One. And then now that we're back at 1, we'll just go back up to the first line and have the same work. The Collatz conjecture with a Z. You had it right the first time. It's not really the exact same thing, but it feels like a similar idea involving sequences of numbers. And it's a famously unsolved problem. This is the actual statement of the function. Actually, oh, it's the exact same 1, 2, 4 sequence, I think. I think if you... I might have it slightly wrong, but I think if you... for any starting integer you want, or for any natural number you start with, if you repeatedly apply this function to it, you will eventually cycle through 1, 2, 4. Or it might be a different sequence of numbers, but it's actually very similar the more that I think about it. It's actually... Oh, Founts, you are saying it's 4, 2, 1. Okay, that part I couldn't remember, but this might be some weird equivalent to the Collatz conjecture, actually, because it does result in the exact same sequence, or like the exact same like ending cycle. Sorry, so yeah, the assertion about the Collatz conjecture, this process will eventually reach the number 1 regardless of which positive integer is initially chosen. Well, I'm not going to solve the Collatz conjecture. Oh my god, it literally... Wait, okay, yeah, if a sub n is odd, we get 3 a sub n plus 1. Is this a... maybe a professor has found a non-piecewise version of the Collatz conjecture. I wonder if Wikipedia knows about this. Oh, here's a sine squared. Wait. No, it's a different context. This is like complex variable, I think. Okay, no, I think this is literally just the Collatz conjecture. It's not even a different version of it. It is just the Collatz conjecture. Yeah, so that's why he put his job on the line. That's why the guy is so confident. Yeah. I mean, that is kind of funny. Imagine if someone did solve it. Like, it's just like a funny like way to like challenge or like to try and get a problem solved. I'll drop the link to this in the YouTube chat as well. For even and okay, yeah. So I guess if you yeah, let's actually like look at that. I guess n+1 or no for even n. What is piecewise function? That I don't know, Papadoria. Maybe the piecewise function gets to the heart of it more in some way. Or like maybe the piecewise function is a bit more obvious what's happening. I guess are we taking a sub n equal to 2k? We would get k plus sine squared k pi. And so we don't even, that's already 0. We don't even care what goes here. And k is equal to a over 2. Or a sub n over 2. Wow. K plus a half plus sine squared. Famished. Is this commutative property? -3 plus 9 equals 6. 9 plus -3 equals 6. Sort of. I don't know if that's where the commutative property starts and stops, to be honest, but the way I think of it, it's more like -3 plus 9 equals 9 plus -3. The statement that you put probably does rely on the commutative property, but I feel like it's not the simplest representation of it. Like there's also other things going on there too. But it's involved there, I guess. 2k plus 1 over 2. That's always -1, right? And then it gets squared. which is equal to 6k plus 4. No? Yes. But no. It's equal to... We need to factor a 3 out, don't we? Am I missing a sign here? Your old phone was ripped? Oh no, 750. Uninstalled the bootloader? Oh, do you have it like jailbroken or something? Why? Or oh, because why to the phone? Uh, should I have chosen 2k minus 1? It shouldn't make a difference, but I don't know why I'm not getting the exact thing that I want here. It's reading jailbreakers for iPhone. Oh, okay. I didn't know there was a difference in terms. That becomes -3 plus 1 is -2. What is k defined as? I guess a natural number. I was just trying to prove that it is the exact same thing as the Collatz conjecture, just so I can see it. Uh, wait, we expect. Oh, what do I expect? 3n plus 1 over, or we want 3a sub n plus 1. Yeah, okay, 3a sub n plus 1 is what we want to get to. Oh, you probably need to do some plus or minus thing, don't you? Oh, I see it. I want to go back. I regret my life choices here. 6k plus 4. You split it up into 6k plus 3 plus 1. You factor the 3 out from the first bit to get 3 times 2k plus 1 plus 1. And then, of course, 2k plus 1 is just a sub n. There you go. Okay, so that's why it's the exact same thing as the Collatz conjecture. That's funny. That's also kind of mean. Okay. You give us such... I don't know, Papadoria. I feel like your professor like hates someone in your class, if not the entire class. Let's clean up some of these pages. Yeah, exactly, Jasu. Oh, you're right. I didn't consider it could be +1 as well, but Wait, sine of any odd number times pi divided by 2. That's always -1, isn't it? Or am I crazy? No, because of 1. Duh. Okay, never mind. It could be +1, and I didn't consider that. But either way, it gets squared away anyway. Yeah, we don't need that anymore. Okay. This is a conjecture yet to be proven. Let me ask Chat GPT to prove it. Let's see if it too recognizes it. I'm sure people have tried that like many times, just asking Chat GPT like the Collatz conjecture and stuff. I wonder what it says. 4k plus 1 is 1, 4k plus 3 is -1. Okay. That's funny. Like, someone jokingly asked me to solve a Collatz conjecture in the YouTube chat at the start of the stream, and then Papadori accidentally comes in and asks the Collatz conjecture also. Uh, Go ahead and ask your question, Colton. There's no line. Try to hear them proceed to say since sine squared is always negative, the sequence decrease eventually will fall and split with 1, 2, and 4. Oh no! Sine squared is always, yeah. Hey, maybe if there's some kind of complex numbers involved, maybe. I don't know if that's even true though, to be honest. I don't know how you evaluate sine with an imaginary input. Do I know that? I don't think I know that. Either way. You know what? I do feel like you can at least score some brownie points with your professor for recognizing that it's the Collatz conjecture, though. You know, maybe instead of quitting his job, he'll like take a leave of absence. You know, it's like partial credit. Shared a question? Let's take a look-see. Ooh, all right. Let's define the set A as a three tuple: sine theta, cosine phi, cosine theta, sine phi. Feels like spherical coordinates or similar. That belong to R3. Okay. And then we have a constraint, I guess, that sine theta minus cosine theta cosine phi plus cosine theta sine phi equals 3/4. If delta denotes the area of the figure formed by elements of set A, and the value of brackets delta is equal to the greatest integer function it's not spherical. You're probably right. Yeah. I was just thinking like the integrating factor comes along with spherical, but it's probably not. Like, it's probably a bad thing to think about here. Or wait, what's the conversion factors? No, the conversion factors are different, right? Yeah, like with like radius equal to 1, but it's probably that's not good. It's not that, I don't think. It's so tempting though. Delta denotes the area of the figure formed by elements of say. So we basically have to figure out how this function looks in R3. Is it basically a plane? Or like, could we think of this as x minus y plus z equals 3/4? Where that's our x, y, and z. But that doesn't have a volume. Is it worth trying to eliminate theta or phi? Gonna play a prank on my students tomorrow, writing r theta phi twice on the board, asking for the difference between them. Zero. Dude, okay, I just can't get on my head. I just so I can like stop thinking about it. What are the conversion factors for spherical? Uh, it's so similar. If rho equals 1, and you swap theta and phi. But then you have to swap the trig functions. Man, it really is just a permutation. Or not like a permutation, but like I can't get this out of my head. Trying to think logically, is very hard of the sinus infection? I bet. If rho equals 1, I mean, that spicy soup, so should be clear very soon. Oh, nice. And if that phi is equal to pi over 2 minus that theta, we would be in business. Likewise with here. We have two different phis going on. Who knows which one is which? Cosine phi to cosine theta, I think as they will be independent variables, like swapping x with t. I feel like yes. Either way, they're going to cover the entire range of possible values that we care about, I think. I have not... Now, this constraint does affect us. It's a sphere of radius 1. I think, but with a piece cut off somehow. And so it actually would be maybe more like z minus y plus x equals 3 over 4. I don't know if this is the right thing to think about, but that's like what it would be. Based off like trying to relate it to spherical coordinates. Basically, convention flips between mathematicians and physicists. Yeah, right. I knew that in physics they flip those. But the thing is, I'm not sure that it's that exactly, Jasu, because the trig functions are also different. I don't think it's as simple as a straight swap. Maybe it is, and I just don't know how to think about it, but I feel like it's more like something that I wrote here, where like it's a change of variables, I guess, but not a hugely significant one. So wait, for whatever reason, I was thinking of delta as a volume, but delta is an area of the figure. Right, it's not a filled in. It's a shell, I guess? Looking for a surface area? That's how I feel too, Colton. Um, this isn't spherical, Jesu is saying. I have a hard time letting go of spherical. Like I think it's a modified spherical, but I think it's based on spherical. I have part of an idea to at least get an idea of what, like, Desmos is helpful here, isn't it? If we take x squared plus y squared plus z squared equal to 1, can we give it the constraint z minus y plus x? Z minus y plus x equals 3 over 4. Ooh. A ring? That's not... Ooh, I guess that is what I expected. That's the intersection of a sphere into plane, I guess. What's the area? Because it's not filled in. Yeah, cool. That's kind of how I feel about it too. But like this is a one-dimensional ring, is the issue. It doesn't have an area. So this interpretation might still not be flawless here. If they give us like if this constraint was maybe like less than or equal to, we could just give the area of the circle, I guess. But it's equal to. Actually, even then, less than or equal to might not help. If delta denotes the area of the figure formed by elements of set A. Figure formed. I guess so. Maybe the wording, the figure formed by elements of set A is that ring. So an issue, I don't know that it's a circle though. This plane doesn't go through the origin. If you cut a sphere with like a tilted plane, can you get an ellipse or something that's just not a circle? Every plane through a sphere makes a circle. Really? Okay. That feels like it's okay, I guess. Intersection of a sphere and a plane is always a circle. Hmm. It's not radius 1, though. Uh, how can we find the radius of this? We need to find the distance between two opposing points? And how can we do that? Use Pythagorean theorem? We still need to find... Yeah, I guess we still need to find some points, but I guess you could look at the ring like that and use Pythagorean theorem from, say, the bottom edge over to the top edge, is what you're saying? And that will get us the diameter? It's just, how do we find any of those points? Normal is 1 minus 1, 1. Yeah, I guess we could eliminate a variable using the constraint equation. Does that just get us the equation for the circle that we want in 2D? Meaning when we go from the plane and interior get the locus of the circle, I guess. Yeah, it seems like that. Now, assuming that I translated the constraint correctly, we could look at x squared plus y squared plus z squared equals 1, and z minus y plus x equals 3 over 4. We could solve this for z. That's not z. That's z. 3 over 4 minus x plus y. And plug it into the equation for the sphere, allegedly. And then just try and get into standard form for a circle. That's annoying to multiply out. That's Wolfram Alpha's job. I'm not doing that by hand. Okay, we get x squared minus 2xy plus 3 over 2x plus y squared plus 3 over 2y plus 9 over 16 equals 1. No! I hate you, Windows. Do not dare to try and just slide a window along only left or right. 'Cause it will adjust you up and down and try and resize things automatically. Okay. Anyway. Let's clean this up. We get 2x squared plus 2y squared. How do we deal with the xy term? That seems like a problem, doesn't it? I feel like there's a more intuitive way of figuring this out. Still unsure what the question is asking. If the xy term wouldn't be there, the circle would lie only in the xy plane. Oh, okay. Maybe I should give the entire thing to Wolfram Alpha and see what it does with it. That's calling it an ellipse? Maybe if it projects it onto the xy plane, it's an ellipse. But in 3 dimensions, it should still be a circle? That's my interpretation of what's happening, Fembox. Huh. Okay, so this isn't simple. Oh, man. Is it not always possible to put an ellipse in standard form? I mean, the area of the ellipse is going to be the area of the circle, though. Hmm. Uh, my interpretation, Jastu, is that this is the floor of the area of the circle formed by the thing that I found, where that's like the border of the circle. That's how I'm interpreting it. Doesn't this plane pass through the origin, and you know the circle has the same radius as the sphere? Our plane doesn't. I think the plane in this example does. I don't know. That's what you meant by Pythagoras? Okay. Okay, yes. Each flowing pairs of equation defines the same circle in space. Hey, Bruce Yang. Hmm. It casts elliptical shadows in the x, y, and y, z planes. It doesn't have a single equation. You have midterms coming up. Gotta lock in. Oh, geez. Good luck. This is what we want, right? What is big R and what is rho? big R is the radius of the sphere, which is for us is 1. Rho is this thing here, which is the distance from the center of the sphere to the center of the circle that we've created, which is just the minimum distance from the center to for the center of the sphere to the plane. Okay. And that's what you're saying too, Jasu. Uh, I would not be figuring this out on my own, but I think this is just the exact thing that we need here. Let me get a screenshot of this and we can work it out. I'll drop the link to the Stack Exchange thread in each of the chats as well. I've seen this formula before, but I don't have it memorized either. It's clever though. So in our case, rho is the equation of the plane if you made it equal to 0. So wait. We take the equation of the plane and we plug in the coordinates for the center of the sphere. Okay. And it's 0. So we get 0 plus 0 plus 0 minus 3/4 over root 1 squared plus 1 squared plus 1 squared. Seems a little simple. Hey, Raven. It's going well. How about you? Hey, Mahir, if I'm saying that right? What is arcsin of phi plus arc cosine of phi? I don't know. Maybe that's an identity. Oh, you know, it's probably equal to something. I'm not quite sure offhand, though. I can maybe think about it after this question, though. You're getting 13 pi over 6 for the area of the circle before you floor it? Okay. Oh, yeah, right. This is a distance, so we can do that. Oops. And this is just what, root 3 over 4? So that's the rho. The small r that we actually want is root 1 squared minus root 3 over 4 squared, which is root 1 minus 3 over 16, which is root 13 over 16, which is root 13 over 4. I guess that's actually bad to simplify it, though, because we're about to square it anyway. A is equal to pi times root 13 over 16 squared, which is 13 pi over 16. That agrees with what Fembach said. Pi over 2? Why pi over 2? Or where pi over 2? Here? Like, over 2 there? I don't think so. Oh, you're probably. Oh, okay. I see. I've heard that one with arctangent. I didn't know the same was true for arcsine and arccosine. Thank you for saying that, though. Can we figure out the floor of this thing by hand? It doesn't seem easy. Um. Well, okay. If we approximate pi as 3, it's a fantastic approximation to make. What do we get here? We get 39 over 16, which we can then approximate or we can say it's equal to 2 point something. And I don't think we're not close enough to 2.9 for this for the rest of pi to probably matter. So I think it's a pretty safe guess that the floor of area is probably 2. Let's look though. 13 pi over 16. Hey, yep, we're good. It's 2. It's a neat question. Actually, isn't that neat? It feels like a very long-winded way of asking you to find the area of a circle. Like a very just like intentionally confusing way. How do you show that arcsine and arccosine formula? Oh, oh yeah, I think maybe I have part of an idea. So, during that question here, one of those JC or like you mean JE? I have no clue. There's just one that this is the entire context for the question that I have. So apparently this statement is true. Um, arcsine of a ratio equals an angle. I think Fenbox is talking about JEE, which is like the university entrance exam for India. But like, is the question like about that, or is it just like you're preparing for that? Oh, okay, nice. I'm surprised that I could actually do that one. That explains why it's such a weird question. Yeah, like the really tough one is called the JEE Advanced. Those are the questions that I usually just back away from because I I I know that you love Unfollows, but I don't love like I'm not a fan of like just like it feels like it's just you have to memorize a shitload of trig identities. It's like, man, I'm not a fan of that. We shouldn't draw an isosceles right triangle. I think the intuitive explanation for this identity I just wrote here is that let's just call this angle theta. because it's a right triangle, we know the other angle is pi over 2 minus theta. So if arcsine of this triangle is equal to theta, then arccosine. What am I writing? Is equal to pi over 2 minus theta. And so if you add them up, the thetas cancel. So I guess that's why. The one that I'm more used to seeing is like, oh, what's the one with tangent? It's arctan x plus arctan 1 over x, I think is the one that I see more often. And I think that's also equal to pi over 2. And I imagine it's because you just take the same ratio but flip it. And it's the equivalent of doing... Oh, cool, you're saying it's arctan plus arc cotangent? Is arctan 1 over x equal to arc cotangent? Abaloo? Even odd, even odd. I feel like the thing that... I feel like arctan 1 over x is the same as arctan, or as arc cotangent. Let me, since I'm not good at this though, let's check it out. For x greater than 0, okay. Yeah, okay, you're right. X greater than 0, they're the same. Nice. This one is really nice for checking trig identities. Because you see, like, very visually, like, where it's true and where it's not true. But I think they all rely on the same idea where you're just taking opposite angles on the same right triangle. That's all it really comes down to, I think. All right, thank you for the problem, Colton. Um, Let me check that off in Discord. Unless there's anything else, I'm gonna get back to doing some circuit studying. But if anyone does have another question, feel free to let me know. Oh yeah, this thing. I'm still not quite clear on what they want me to guess. Once I went back and reread the part of the chapter that talks about this. I think I'm going to take a peek at the first sentence or two of the answer because I thought I guessed the right thing, but I'm getting something that's not quite conclusive. And when the book looks at the different cases, I think the word in the question is specifically telling me to guess only an exponential. But when the book goes to work it out, they guess an exponential times cosine omega t. So I'm going to take a little peek at the answer. Chapter 8, number 4. The first part of the answer, anyway. It is this. Okay. Yeah, that's what I get too. So let me, before I look further, we're right so far, right? Yeah. Now the thing that I don't like when we follow this path is following down, is figuring out what happens with large R and large T. Should really clean up my notation. Take a moment in that step. Take a moment in that step. Yeah, the thing that's still kind of my head around is like, if beta 2 is going to 0 and t is going to infinity, that can be any number you want. You can't really conclude anything from that. I know that in overdamped circuit, it should just go to 0. I'm not seeing how that's justified from the math, though. Maybe they mean a large but finite R in infinite T. That could justify it. Let's take a since we know we've done at least the first part of the question, right? Let's keep peeking. Taylor. Damn you, Taylor. Skinner. Root 1 minus epsilon is about 1 minus epsilon over 2. You never suspect the Taylor series inquisition. I need to remember to use these things more. Root 1 minus epsilon is about 1 minus epsilon over 2. What's happening here? So beta 1. Ugh. Look at me evaluating limits like someone who studies math. Where someone who studies physics just gives themselves a way easier problem by taking advantage of Taylor series. Presumably a way easier problem. I haven't actually gone down this road yet. R over 2L 1 plus root 1 minus 4L over CR squared is about R over 2L1 plus. Now, epsilon is 4L over CR squared. So the 4 becomes a 2. So we get R over L, because we multiply it by the 2 in there, minus the 2 L's cancel, CR. Which is approaching infinity. Still, that's consistent with what we found previously. What about beta 2? R over 2L, 1 minus root 1 minus 4 over CR squared. Exact same thing, but we'll have a minus inside now. R over 2L. No, wait. That factor goes away. Because it's 1 minus 1 now. We get just positive 1 over CR. Which goes to 0, clearly. Wait, still, that's the same thing. Don't we have the exact same issue? Yeah, this doesn't help me. It's an easier limit, but it doesn't help me with my actual question. What's a show and tell? Basically, I try to find something interesting to show and talk about. Just like you would do when you're a kid doing show and tell. I don't know what I would show right now, though. I could show off a coffee maker I bought like a month ago or so. I don't know. But yeah, it's just like a for fun thing. I just try to find some interesting object around the house, basically. Um, Beta 1 is much bigger than beta 2. So the first part goes to 0 much faster than the second part. For large T, it looks more like this because that's farther away from 0. The same behavior as an RC circuit. A very large R means very small current I, hence very small di dt. The voltage L di dt across the inductor is therefore negligible. Huh. Hey, SG1. I was thinking about this the wrong way, which is very typical. That's kind of cool. So let me, I guess, maybe write this out in my own words. I need more room. Is there an easy way to get a page after? Ugh. No, I gotta go to the sidebar. Okay. So, um, the so we're not taking the limit as r goes to infinity. We just are considering a large but finite r. For large r, b of t looks a hell of a lot like beta or be to the minus beta 2t, which is approximately, again, an approximation of an approximation. Looks like minus 1 over rct. Which is the voltage for an RC circuit. The inductor doesn't matter because it doesn't have much current to work with in the first place, more or less. It's not going to have much of an influence in the circuit. That's what they're saying. Okay. And so all that, I'm glad I actually did 4 because I feel like I learned something there and I didn't think that I would. Or I wasn't sure that I would, but... But 6 was the one I was actually interested in doing. So if r goes to 0, verify the solution to equation 8.4, correctly reduce it to the solution for an LC circuit. Hey, Reaper. Hope you're doing well. What is alpha equal to? Let's find the equation for... Let's find the context for equation 8.4. Alpha is r over 2l. Perfect. Hey, Scorpra. Hope you're doing well as well. Did I say r over 2l? I did. That is a terrible alpha, by the way. So v of t is a... Wait. Doing well, it's good to hear. The drum cat. Love it. I just love how serious the cat looks as well. Like it's very dignified. Do I want to care? I assume I don't. I was wondering if I want to care about the full, like the actual general solution. I feel like they said equation 8.4 though, so maybe we just stick with equation 8.4. And they said that, yeah, I think you do. Drumcat means bit business, exactly. 2LT. cosine omega t. Colded, I personally hate chemistry. What is your opinion on it? Just asking casually. I want to like chemistry, but I'm not into it. It's too much memorization for me. Um, so yeah, I don't like it either. I thought I liked it until I took an actual chemistry class, and man, maybe it's the kind of thing where like if I got into the more advanced stuff, I would like it more. But yeah, it's just too much memorization. As r goes to 0, this thing, the exponential goes to 1. So that's a pretty straightforward limit, I'd say. You like chem, but you don't look at it very often. Fair enough. Really, we should be approaching 0 from the rate here. But this is physics. We don't care about that. Either way, it's still true, but I feel like given the situation, we're not going to consider negative resistance. uh... And I guess this is the solution for an LC circuit. I would go back and verify that, but who cares? You got a 3 out of 100 in one of your chemistry tests? Oh my god. That sounds like a brutal test. Hey, Punching. How's it going? And the L goes to 0 limit. Verify the solution in 8.15. This is to the solution for an RC circuit. These are also problem 8.4. There's no questions in queue right now, Punching, so feel free to let it rip. This is easy, I just can't bear studying it. Aw, dang. Ugh, what am I going in there? 1 minus 4L over CR squared. Just let me know where it's posted, Punching, once you do post it. Once you're putting it there in chat, obviously. Multivariable exam coming up this Saturday. Ooh. That works. Let me pull it up. Stay a multivariable kind of day. Oh my god. I feel like the last few streams, things have been happening in waves. We're going to use the exact same formula that we just used in a previous question before. That's funny. So there's a formula for the distance from a point to a plane, Punching. Do you know that? Yeah? Okay, so let's I happen to have it right up here. um Let me rewrite it in a simpler way though. If the plane is ax plus by plus CZ equals D, and that's X naught, Y naught, Z naught, minus D? It could be, it's, oh, wait. Yeah, it is. I think so. I'm pretty sure it is. Let's verify that. But I want to make sure that problem wasn't specific to the context. Exam side, I didn't think about that, Fembox. That is kind of messed up. An exam on Saturday. Oh. Oh, okay. So it depends. It might be plus D punching. It depends how you're defining your plane. If you define the plane to be like this, it's plus D. If you define the plane to be the way that I did it, it's minus D. So it's the same thing, but if you're given it with plus D, I'm gonna use that version of it. So in that case, we're defining our planes to look like that, and that's okay. So then the distance D is the absolute value of the plane evaluated, or it basically like you take the equation for the plane here, but you plug in the points for X, Y, and Z. So A is 2 multiplied by -3 plus, hey, Jokerman, I don't have that command set up offhand. If you click on your name, though, you can see it. I think even following February 2023. February 20th. Wow. So you are one of the OGs. I do remember you. It's been a minute. But that's maybe like a month after I started my very first stream. Hope you've been well. Okay, so now B is 2, Y is 6. Now C is 4, Z is 1. And then D, we do have to write it like that, is 4. Yeah, it's because you have to add the 4 to the other side if you're going to use the formula in this way. The bottom is 2 squared plus 2 squared plus 1 squared. So I assume that's the source of the issue there. So I'll go through and like follow the actual calculation, but that's probably just the problem right there. -6 plus 12 is 6, plus 4 is 10, plus 4 is 14. 4 plus 4 is 8, plus 1 is 9. The root of 9 is 3, so 14 over 3. Oh no, I've been streaming for just over 2 years now. My first stream was like January 18th or something. Around there. Gives me nostalgia since I remember I was still in high school watching you do math. Oh, are you in college now? Or university? University in business. Nice. Business is awesome. I just got called old. That is the first time someone said they have nostalgia for my stream, I think. I have like YouTubers slash streamers I've been watching since I was in like 7th or 8th grade. I feel nostalgia for those. Need to relearn math. I kind of forgotten a lot of the algebra. Oh yeah, I bet they normally make business students do like a calculus for business type of class. If you have a question or something you want to like hear more about, feel free to let me know. But if you're just chilling, that's cool too. OG math Twitch streamer. Maybe I'm becoming like that. I don't know. I think like Penn Center's been going for like at least a year longer than me. Same with OB, I think. OB might be one of the longest. And Gold, I have no clue. That before me though, I think. Definitely. Um, Zach was a couple months after me. Dan is a couple months after me. Basically, everyone else is a couple months after me, as far as I know. Physics and depression, I guess, is also a real OG, unlike me. I don't know where the line is. Bulge. I will say that the networking between us all though is like pretty new. As far as I know, it's pretty like siloed off before, and it's pretty great to have everyone like know each other and support each other. Remember the good old whiteboard days? I remember them too. I still would rather use a whiteboard for my stream. It's just I want to like have a nice looking setup. I don't think it looked nice the way that I had it, and it was a lot of work to maintain it. So that's still a dream, but that's like owning my own house and making a streaming office or something type of like thing for me to bring the whiteboard back. I think I still have the one that I was using right off to the side here. But I don't know, just the old tablet with Journal Plus Plus is a lot easier and it just looks better, I think. Whiteboard days until fairly recently. Yeah, I don't remember the exact date. We could scroll through my YouTube videos and see. You know what, let's do that. I don't have anything else to do right now anyway, besides the AC circuit stuff. Let's go down memory lane. Oh, wow. We already hit it. I can see the whiteboard in the background there. Was this one also a whiteboard? No, that was right when I was transitioning, I think. So September of last year. Is when I switched. Your Wi-Fi cut out there? VR math streams? I think some people would, I would actually, if I had a VR headset, I would actually try that. If that was even a possible thing. Joker man, your Wi-Fi cut out. If you have something you want me to talk about, feel free to let me know. But if you're just chilling, that's cool too. But it's kind of funny you say VR because like at one point, Talos mentioned like VR chat or something like that being a possible venue of like, you know, tutoring or teaching, and that's kind of like a cool idea. I think would appeal to a a good amount of people. What about the blue book? I haven't gotten back to the blue book yet. I'm still on chapter 5. Talk about where I play for Masters of Physics. I don't know. I'm debating about whether I want to talk about the actual places. I feel like I should like. I feel like it shouldn't matter that much if I say it, but I just feel like I don't know all the consequences of it. That's the only thing that's kind of like holding me back. Colda posted a linear algebra one, and David Medina Marin. I'm best at helping with like first and second semester of calculus and below. If there's like something that's beyond that, like differential equations or linear algebra or something, I can try with it. But that's where my knowledge gets like more sketchy. It's like this one right here. I'm not sure if I can actually do it, but we'll try. So if I can go ahead and ask your question, I can tell you whether I think I can do it or not. But yeah, my comfort zone is like calculus and below, I guess. Let f of x denote the number of elements in a matrix X which are equal to 0. I will say I mostly applied to places based off the location and not really about the academics. I did not take a PDE class. I had a class that like dipped its like just kind of like talked a bit about the heat equation and the wave equation. I hardly remember it though. Actually, it's the same thing with my last name. Like I don't really care that much if people know it, but I just feel like I'm not fully informed if I do say it. Caltech it is. No, I applied to like the safety school is the one that's local to me that I wouldn't have to move for. Every other school I applied to, I'd have to move. It was important to you though, just like I would absolutely DM it to you. Just like saying it publicly or not is what I like don't know about. F of x denote the number of elements in matrix X which are equal to 0. And fancy A is f of the adjoint of x, where f of x equals 0. X equals xij 3 by 3. Xij belongs to R. Well, that didn't apply to UC. Seems like they're having issues maintaining math faculty. I did apply to 1 for math, so hey, maybe that'll help my odds with getting in. Because I'm honestly not confident. Okay, so this linear algebra one, I'm pretty sketchy on. I'm not sure I'm gonna. This is gonna take me a lot of googling. Let me look at David Medina Marin's question. I think Colded. I'm sorry, but I'm gonna put this one on the back burner because I think David Medina Marin's question I can probably figure my way around. Riho or Rego, I'm not. That's a crazy integral that I'm not going to do. I can link you to a video where Black Pen Red Pen solves it though. Okay. That's the black pen, red pen video right there. I'm not doing that by hand because it's kind of insane. And if someone has an idea for the one up top there, do feel free to shout it out because I'm gonna need to Google a lot of things. Are you just giving me complicated integrals, Rijo? I'm not doing that. I'm sorry. Legendary streak has been stopped. Fizzbuzz got it actually. It's the first one of his that I can recall. Oh no, second one. So, this is y prime plus y equals some function x of t. But we have x of t is equal to e to the minus 3t u of t, interestingly. We don't know what u is. Not quite 50, dang. A prime number u. That's a good thing you didn't say that about 17 first, because I feel like Penn Center would have to fight you. LTI system? I haven't heard of LTI. Is that like a circuit? I don't know what the T would be. Either way, the homogeneous. You're always late to everything. For the homogeneous, we should know that the homogeneous solution prime plus the homogeneous solution equals 0. In this one, we can just solve by inspection. I would say it's just e to the minus t. And if you want, you could plug it back in to find the derivative of that, minus e to the minus t plus e to the minus t equals 0. I should say it's some constant times that. Would have been 10 firsts in a row. Oh, it would have been? Dang. I didn't realize you've been tracking the first streak. Hey, Rijo. Oh wait, causal LTS, not casual. There isn't a second solution, right? No, yeah, it's only the one homogeneous. So we don't need C1, we can say just C. So is u of t just a generic function here that we don't know? Or is it? Okay, yes. Interesting. U is a unit step function? Oh, okay. That would make sense if it does come from like a circuit. Um, how do you find the for getting the particular solution, I normally uh we'll do it a different way. I feel like you don't need to go down this homogeneous route if you just use an integrating factor like Collatz says. There can be a lights out command. I just feel like it would look bad. I can turn off the lights manually right now if you want to see how it looks. I guess it's pretty bright out right now anyway, so it doesn't make much of a difference. But that's what it looks like if the lights are off. My blinds are open though, so it's kind of light inside here anyway. Um, I feel like looking at the homogeneous versus particular way is implying something. It's just like not the way that I normally do it. It's possible and it's valid, but I normally just do it with the integrating factor and get them both at once. Alright, Spetry. You thanked me for hanging out? That's my line. Thank you for hanging out. Sleep well, though. Regio pass. You're just giving me complicated integrals for fun, it looks like. All right, the integrating factor. I should really just know how to derive this, but I don't. It's e to the p of t and p or integral p of t, and p of t is the thing in front of y. Okay. P is just one here. Some constant I'll call big C, I guess. And the solution y is equal to 1 over, well, we can call that c e to the t. But I feel like we don't want that constant there. The constant comes in the next part. Yeah. That's I really just need to learn how to derive it. Integrating factor times that thing. And I'm going to prematurely add in the constant of integration c, just remember to bring it in later. So y is, the exponents add here, so minus 2t u of t, oops, dt, plus c e to the minus t. This is the homogeneous part that we just got before anyway. You remember? Yeah, I think I did the same thing, Penbox, using Laplace transforms. David, the part where I'm stuck here is I don't quite know what to do with this integral. Hey, 750. Just going through all those redeems. So that's the part where I'm a little like weirded out, where like we could just leave it like this, but if u of t is the unit step function, like Fenbox is saying, 0 for t less than 0, or 1 for t greater than or equal to 1, if it is this thing here, we can make a solution that's just valid for t greater than or equal to 0, sorry. So that's why I'm not sure how to think of this problem, David. This is kind of difficult way of doing this where I just don't really have the context of what you do and don't know. Well, what is a causal LTI system? Linear time invariant is LTI. Oh, is this convolution? Oh man, convolution I remember even less than Laplace transforms. You know none of this? I'm feeling the same way, Scorpora. It's great, but it didn't really stick. Yeah, so I don't think I'm doing the technique that you're supposed to be doing here, David. And it's been way too long for me to remember how this technique even works. Yeah, I'm sorry, David. I think this is a little too far out of my comfort zone. If it was just a normal differential equation, I could do it, but that U of t function, I don't know how you deal with that in this context. So I'm sorry, but I think I need to put a pin in that for now. I think I might go back to Collatz linear algebra question here. F of x denote the number of elements in a matrix X, which are equal to 0. Sum of elements of set A. What if an adjoint matrix again? The cofactor? Oh. So, okay, the cofactor for A is the determinant of the 2 by 2 in the lower right. I think we're probably thinking more about a property though of adjoint matrices than the actual definition. Hey Central, 10 streak, nice, nice. Wait, so is ADJ adjugate? Adjoint or adjugate? Okay. Uh, so I assume there's gonna be a property that's relevant here. We're interested in counting the number of zeros in a joint matrix that originally has no zeros. That's 3 by 3. I think that's basically the question. Wow. $37? Is that just a random guess? Have any number of zeros from 0 to 9 except 8. So are you summing 0 to 9 minus 8? Yeah, Collatz, same. The sum of the elements of set A. Oh, okay, so I see. Okay, yeah, you're... That A is a set. So what number of zeros are possible? What is the sum of the number of possible zeros in adjoint matrices where the original matrix has no zeros? That's the question. Mew, 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 mew. 3 by 3. Okay. And so presumably, oh no. I'm about to say that you could just do the zero matrix in order to get 9 zeros, but the zero matrix that doesn't meet the original qualification of having no zeros, does it? Maybe the matrix of all ones would give us all zeros, though. Yeah, I think I buy that. F? Oh. I think that's just on your end punching. I haven't dropped any frames that I see. If it's lagging for anyone else, though, do let me know. Um, so I think that maybe the easiest case for me to think of, at least, to have 9 zeros, because the adjoint of the matrix of all ones. I think if I, by my quick mental math, is the zero matrix. So 9 is in fancy A. You're only restricting rows and not columns, so I bet I'm wrong. Oh. I bet there's a systematic way of doing this, but my linear algebra is pretty terrible. So my best thing is to just guess, or like, like just kind of mess around with it. But there's only, 0 through 9 possibilities, thankfully. So it could be a lot worse of a question if they give us like 4 by 4 or 5 by 5 or something. Can we think of a way to control the number of zeros? Like, if we took the example I gave and randomly threw in a 2 somewhere, what would that do? Like if I put a 2 right there. This might be a job for Wolfram Alpha. I don't know if I want to do all these calculations by hand. I mean, this one might be simple enough. I think once if you have 2 zeros in a given row of adjoint x, that third element in the row also has to be a 0. You're looking at the result and reverse engineering what's possible. That's probably a better way of doing it. I guess you have to also consider columns and diagonal, though, or they could be arbitrarily placed. I don't know. I'm gonna keep on. That will be a 0. This one is gonna be a 0. 0. This one you get -1 here. This one you get -1. This one you get 0. Oh, you have to transpose it. Just cheat and do that because we don't actually care about the transpose piece, I don't think. This one, -1. -1, 0. So I just constructed a case with 5 zeros. We don't have to care about zero zeros because that doesn't affect the sum of the elements. For 1 0, I feel like that's possible, you know? Why wouldn't it be? That's a terrible like logic to use, right? I don't see why any of these wouldn't be possible. So that's problematic logic. Um, how much wood could a woodchuck chuck if a woodchuck could chuck wood? 42. Hey, Pradyumna. Yeah, nice to see you too. Hmm. What time is it? Oh my god, okay. We're still good. Can you guess to 20? Okay. I completely forgot about Zach's class until just now. But we still have over an hour until it starts, so we're okay. Like I feel like I shouldn't just be guessing and checking, but I don't quite know what else to do here. What if I have two twos? Say right there. Um, like that. So I just found two. Hmm. I there must be a slicker way of doing this. I shouldn't just keep on guessing and checking. What is it about this that produces zeros? I'm maybe taking too simple examples because I could get misled and think that you need to have four of the same number, but that's not really true in general. You just need to multiply to the same number. The pairs do. I might Google this because I think that there's got to be a better way. You're only showing me images? It's gonna, I know I'm not showing my screen, but let me look at these. These aren't right. Why is it showing me images and not websites? What is it doing? Google's behaving super weirdly right now. You test tomorrow, Alpha Gorilla. You understand now? Awesome. Good luck with your test. Aura? No, that's not it. Hey, Boss Dad. Hell yeah, math. Welcome in. Right now we're working on this problem. I dual stream to Twitch and YouTube, and this is from Colded over in the YouTube chat. It's a linear algebra question. It's a bit of a doozy though. My linear algebra isn't very strong. Glad to have you here though. I've gotten a little bit stuck, so I'm just Googling it right now, or seeing if I can find it on Google. So wait, what's the relationship between the adjoint matrix and the original matrix? It's related to the inverse, I guess. We do know that. I don't know that if that's helpful. Linear algebra not my favorite. I don't mind it, but I just don't know enough about it. Yeah, I agree. It's useful. Since you're new around here, if you're interested in math streams in general, I just like to, whenever I see a new person, I just like to let them know that there's actually a niche of math streamers. It's not just me out there. So if you're interested in like math streams in general, there's like a whole list to get you started. And there's even more than that too, who are always like popping up. But yeah. Um, I don't think the inverse bit is helpful that I can figure out. Not a fan of statistics. Uh, you're not alone in that opinion. I don't like stats as you learn it in like your first stats class or whatever, where you have to memorize a bunch of like p tests and z tests, or not. Yeah, I guess like a p test, but like the difference between like z tests and t tests and chi-square tests and just like all those different things you have to remember. I did take I think it's called engineering statistics course or something like that, where you learn how to build the distributions, and I thought that was kind of cool. Um, Stats isn't generally my favorite though. Statistical mechanics, no, not that, Territar. Not, I've never taken a class in that. It seems not simple though, from what I've heard. I think it was called engineering statistics, but it was basically like in order for a given function to be a probability distribution function, the integral over its domain has to equal 1, and going over definitions like that and applying it to functions. And I think there's some other things in there too that I can't remember now, but Markov. I'd love to learn about Markov chains. There's just one that came up on Tuesday, I think, where in the Discord Fizzbuzz posted a solution problem that I got stuck on that uses Markov chains, and it was pretty cool. I might still have it pasted in, or not the solution, I still have the original problem pasted in here somewhere, maybe. I might have deleted it. No, yeah, it's this one. Involving a dice game. You can apparently use Markov chains to model this game. At least if you only consider it the addition piece. If it's subtraction, it gets a little bit more complicated. I have a bachelor's in applied math, and I'm applying to graduate school right now. I also have a minor in computer science. Um, it's annoying. It's not. uh, this definitely is not popping out at me, and I really don't want to keep on guessing and checking. I feel like that's just not a good technique. I'm interested the most in dynamical systems, but really, it's pretty broad. I don't have a very narrow like thing that I'm super interested in. It's like dynamical systems, any kind of like modeling. Um, what else was I saying? Honestly, it kind of escapes me now. I don't have a very like narrow focus though. I just like to see math when it actually can be used to a real world situation. So place I was looking at, they were like doing climate modeling, biology and ecology modeling. There are also some physicsy things that looked cool too. Uh, the terminology they used was pretty foreign to me though, so I don't even remember what they were talking about. Nonlinear waves, I think, was one that came up a lot. But yeah. You don't say if you don't want, but what's your background? civil engineering. Oh, nice. It's kind of funny. Like I like applied math, but anytime I see an engineering problem, it immediately feels kind of scary to me because it just feels like everything is kind of like flipped on its head from what I'm used to. I know. I think I'm back to trying to make Google work for me here. So I spend looking at a problem, having no idea where to even start. Ugh. All right. Well, I'm glad I'm not alone then. Engineering is built on top of physics, as far as I've seen. Yes, but it's like really specific in niche physics. Like, or even the other day, someone asked me like the tear strength of fabric, and like they have different values depending on if you're tearing like, or I my guess was that they're like two different values for the tear strength though, and like my guess was that one of them is like going with the fibers and one of them is going across the fibers, but it's like, man, that's just so like niche and specific that I don't know what to do with that. None of these things like are talking about adjoint matrices. Hmm. Or like not in this like it's either talking about the number of zeros or adjoint matrices, but not both. Um, I think I'm just stuck on this. Hold it. I'm sorry. Fenlox is calling a 0, 1, 2, 3, 5, and 9. Really? And so you were thinking about it in terms of constraints? For my final pure math course this coming semester, which is Calc 4. Oh, like differential geometry type stuff. I never actually had to do that. But I think that that does get used in engineering type stuff. So that seems like it makes sense. Yeah, Raven. I don't know enough about it to really describe it, but I think there's things like you can consider like it may maybe like a curved like surface, like if you took a square and just like gave it a curve, and you can consider things like what happens if you made it slightly bigger in like the dx direction or something like that. I think that's the type of thing it might deal with. I'm honestly I'm not quite clear on it myself, though. We could Google it because maybe it's good for me to know that too. Maybe I wasn't completely off from the look of these pictures, at least. Yeah, if you want, Boss Dad. I think the trick is that once you put 2 zeros in any row slash column of adjoint x. All right, let's think about that. Sorry, you did say that before, and I got distracted again, didn't I? Once you put any 2 zeros in any row slash column of adjoint of x. Thank you for the follow, Boss Dad. Put 2 zeros in any row or column. So if I just pretend it's that, just for the sake of argument. You're saying I shouldn't do that though, right? I don't know. The other element in the same row slash column. Or no. What you're saying is that if I don't know, say what this third one is, it has to also be 0 as I'm calculating the adjoint. Almost like tic-tac-toe or Sudoku. Okay, and so that is consistent with the examples I got up here, right? Why must that be? When I was looking at this matrix up here, these first two elements both gave zeros. I mean, I feel like this is too simple though. But if I do just accept that as true, if that's our only constraint, then I guess we're able to count it so we can... As long as we're not violating that constraint, we can have anything we want, I assume. So... it's possible to have a matrix with... Or it's possible to have the adjoint come out with no zeros at all, which isn't even important to consider, but just for completion. We can put just 1 0 here, and we haven't violated our constraint. Maybe instead of doing it separately, we can, as long as we're careful about the constraint, we can get a second 0 in here, like there. We cannot put it here or here or here or here, though. We could get a third 0 if we say put it here. Yeah, no worries, Boss Dad. We could get... Is it possible to get a fourth 0? Not that I see. So yeah, it looks like 4 should not be included in the set here. 5 we can do, because as soon as we try to put the fourth, well, not there. I've kind of screwed myself, haven't I? This is a bad arrangement. Let's say this is the 3 that we're starting from. If we were to put a 4th right there, because of our constraint, we'd have to automatically put a 5th there. And so I think a 5 can only exist like in an L shape like that. Or, you know, reflected around. And so similarly, I can't figure out how we would get a 6th, 7th, or 8th one in there without having to then add another 0. So we can, and then that's true all the way until we get to all 9s. I guess so. All right. I'm still, I still haven't quite figured out for myself why that constraint exists, but if I accept it as true, then I buy that answer. Course split into 2 broad components, each of which is comprised of a number of subtopics. The first component covers advanced ideas in linear algebra, ordinary differential equations, and vector calculus. Both analytical and numerical solution methods are introduced. Ooh. So that's not differential geometry, or maybe there's also an it's going to get involved there too, but that sounds more like Calc 4 is a mishmash of differential equations and linear algebra, and apparently vector calculus too, which they say exactly. Well, I guess the second component might be something else, but that sounds like a cool class. I think I'd enjoy that class. Okay, I don't know. Are you still here, Colton? If not, I'll type back to them in Discord. And I might make that my last problem of the stream here. See how it goes. Yeah, it could be a difficult class. It's kind of on the professor, I guess. Okay, I'm not seeing Colded replying in chat. We might wrap things up here for the day then. You think you improve your result to involve to try and put it in Twitch chat? All right. Do it for 4x4 matrices. As long as Fenbox's thing still applies, I don't think that'd be that bad, Phobos. I just don't know how. No, yes. uh. All right. I think I'm gonna maybe wrap things up for the day then, so I can have some time to rest before class. So in 1 hour, for anyone who doesn't know, Zach will be doing the real analysis class that I plan to be on the call for. I want to get a little food before that though. Let's cut the YouTube stream off here. So Terratard, Alpha Gorilla, or Pregemna, or anyone who's here on YouTube, thanks for being here. We're back on Saturday.